All right, so in this video, we're going to talk about solving equations, which is kind of general. We're going to do a lot of radical equations since we've been talking about radicals, but also just some different types of equations that I find are good ones to do because a lot of times they're easy to make mistakes on these types of problems. You'll see what I mean as we get into this. And it's probably time to talk about the quadratic formula, which I'm sure many of you have seen before. And so we'll review that. So, and also just to note that we're going to be interested right now just in real solutions. As some of you know, sometimes you can get imaginary solutions. For example, if you were trying to solve x squared equals -1, we could say that x is equal to the square root of -1, which we'll call I. That's an imaginary number, and we're not going to get into that right now. If you move into some higher math classes, you might have to relearn that. But for the most part in calculus, we're not going to have to deal with imaginary numbers. So that's what we mean when we say we want real solutions, no imaginary numbers. We're not going to worry about that. Now, this one is a very common problem to make a mistake on because it looks like a form that we're used to. For example, if I had x minus 3 times x minus 1 is equal to 0, we know by the zero product property that if two things are multiplied to equal 0, it means each of these could be 0. Either x minus 3 is equal to 0 or x minus 1 is equal to 0. But if I have, it looks the same, but if this right side is not 0, you can't just set this equal to 8 and this equal to 8. And the reason why is because if you think of two numbers that multiply, right, if I give you a number for x, we're going to be multiplying two numbers here that equal 8, there's lots of possibilities. This number could be 1, this could be 8, this number could be 4, that could be 2, this could be 16, that could be 1/2. There's way too many possibilities. The only way we can really conclude anything is if we have a number or a number times a number or a factor times a factor equal to 0. Because again, the only way two numbers could multiply to give you 0 is if one or both of these is 0. So what does that mean? We do need to make this equal to 0. And unfortunately, that means even though it was nice and factored, we're going to need to FOIL this out. X squared minus x minus 3x plus 3, and then subtract the 8 over. So we're going to subtract the 8 from the 5. This is going to become x squared negative x minus 3x is minus 4x. We'll subtract the 8 over from that. That's going to leave us with minus 5 equals 0. And that will factor two numbers that multiply to -5 and add to -4 would be -5 and +1. So now we can use the zero product property and say that either x minus 5 is equal to 0, which means x is equal to 5, or x plus 1 is equal to 0, so x would be equal to -1. Okay, so this is only useful if the right side's equal to 0. Okay, the next one is another one that I find is a very, very easy problem to make a mistake on here. And the reason why I don't usually do this, but I'm going to show you what making a mistake, I'll put common mistake. Sometimes hesitate to do this because I don't want you to think, I don't want you to lead you into the wrong direction when you see this on a video, but if there's something that happens wrong, that happens very frequently, I like to point it out to really highlight why you can't do this. So a very common mistake would be to do this. Hey, why don't I just divide by x squared? So I could get rid of it here. This would be 64. If I subtract those exponents, I get x squared. And I can just tell there that what are two numbers I can square to get me 64? That would be plus or minus the square root of 64. So x would be plus or minus 8. Now, you might look at that and say, well, what's wrong with that? How can I tell if these answers are correct? Well, I could plug them back into the original equation. And if you do plug that in, start with positive 8. What you would see is 8 to the 4th. I don't know what that is, but what would happen if you plug the 8 in there? and you rewrote 64 as 8 squared, and then you plug the 8 into there, you get 8 squared, and you get 8 to the fourth. And when we add those exponents, it's 8 to the fourth. So it works. And you can do the same thing for -8 because if you raise them to even powers, it's going to be the same as +8. So the issue here is not that +8 and -8 are not answers to this equation. It's that we don't have all of the answers. Take a second and think about what's a number you could plug into both sides of this equation and make it true. Don't think too hard. You'd have to agree 0 works, right? If you put 0 in here, 0 to the fourth is 0. You put 0 in there, that's 0 times 64 is 0. So another answer is 0, but you can tell if I solve the equation this way, I'm not going to see that 0 as an answer. Okay, so we don't want to do it this way. So the mistake is this. It's very dangerous to simplify an equation by dividing out variables. Sometimes it'll work, but a lot of times you'll run into a problem like this one. So instead of dividing both sides by x squared, what we want to do is move it over to the other side. And just like we do with quadratics, pretty much any equation that has higher degrees than 1, you're going to want to move it over and make one side equal to 0. That's the safe way to go. And instead, then I can factor out an x squared. And I can factor that further if I want. That is x plus 8, x minus 8. And then I can use my 0 product property. If I set this one equal to 0, I'm going to get 8. If I set this one equal to 0, I'm going to get -8. And if I set, here, I'm going to write that one. If I set x squared equal to 0, well, the only number that you can square to get 0 would be 0. So then I get all 3 of my answers. All right. Moving on. So now I have x squared minus 4x equals 6. That has a degree higher than 2. So as I just said, we're going to want to move everybody over, set this equal to 0. Move them to the left side. And then if you look at this, the normal instinct should be to factor this. But if you try to factor it, you'd be looking for two numbers that multiply to -6 but add to -4, and it isn't going to work. This is not factorable. Not factorable. At least not with nice numbers. Okay. So when that happens and it's a degree 2, it's a quadratic equation, we're going to go with the quadratic formula. And the quadratic formula says if you have a quadratic degree 2 equation that has the form of ax squared plus bx plus c is equal to 0, that the answer to this, and perhaps later we'll talk about where this comes from, is -b plus or minus the square root of b squared minus 4ac all divided by 2a. And that is definitely a formula. You know, I said I'm not very big on memorization, but it's kind of in your interest if you remember that. And I'm guessing many of you kind of already maybe have that in your memory from using it many, many times before. So that's what we'll do here. So for this one, our a is the coefficient of x squared. I could always imagine a 1 there if I wanted to. B is the coefficient of x, and you have to take the negative. It's -4. And c is the constant hanging out at the end, which in this case would be -6. So then plugging this into the quadratic formula, I'm going to have -b, so the negative of -4, plus or minus the square root, b squared, minus 4 times a times c. And we'll divide this whole thing by 2a, so 2 times 1. Negative of -4 is +4. -4 squared is 16. But then this negative times a negative, all this is multiplied, but I have two negatives. So that's actually going to be plus 24 over 2, which is 4 plus or minus 16 plus 24 is 40. And good practice, as we were working on previously, we're going to want to reduce this square root. There's a perfect square factor in there, right? 40 is 4 times 10, which means it's 2 squared times 10. So that 2 is going to come out in front. It's going to be 4 plus or minus 2 root 10 over 2. Now here, the radical has all the perfect squares taken out, but we can take it one step further to simplify this. Anytime you have a fraction with one term in the bottom, what we can do is we can divide this up. So we could make this 4 over 2 plus or minus 2 root 10 over 2, which is 4 over 2 is 2. And the way it works here, you can't cancel the 2 with the 10. The 10 is locked inside that square root, but you can cancel these 2's outside. And 2 over 2 is just 1. So it's just 2 plus or minus root 10. And remember that this is giving you two answers, just as a reminder. One answer is 2 plus root 10, and the other answer is 2 minus root 10. But if you can leave it like this, I just want to remind you that it's really telling you two answers there. Okay. So next thing here, this is a different type of an equation. It involves a radical here. We have the square root of x plus 7 equals x plus 5. And in order to solve that, what we'd like to do is get rid of that radical. And what's one way I can do that is I can square it. I can square, but if I square the left side, that means I have to square the entire right side. You can't square this and then square these individually. You have to square the whole thing with parentheses, because that's different. Now remember, the square root of something squared cancels out. Why is that true? Because you have x plus 7 to the 1/2. And if you square that, we're going to multiply those powers. We're going to end up with just x plus 7 to the 1st. So this is just x plus 7. This is not the same. Remember, you can't distribute this. If I wanted to do this one here, we'll do it off to the side. That is x plus 5 times x plus 5. And we're just foiling here. So we're going to have x times x is x. We're going to have a 5x, another 5x, and then 5 times 5 is 25. If you can do this in your head, that's actually ideal. You wouldn't have to show the work in most classes. At some point, you want to be able to do that in your head. Think of that as x plus 5 times x plus 5, and then, whoops, I didn't write that as x squared. And you can, if you even realize that you're going to end up with two 5x's, you could combine those in your head to 10x. I've got an x squared, so I want to move everybody over, make one side equal to 0. It's probably easier to make this side 0. So we're going to subtract an x. That'll make that 9x. And we're going to subtract 7 from 25. And if I subtract 7 from 5, I get 18. So now, yeah, we just talked about the quadratic formula, but I usually like to give factoring a fair shot before I use that, because sometimes you could make matters worse using the quadratic formula. Two numbers that multiply to positive 18 add to 9, x plus 3, x plus 6. And it's equal to 0. So what would make x plus 3 equal to 0 is if x was negative 3. If I set this one equal to 0, what would make it equal to 0 is if x was negative 6. Okay. Now, here's the deal. Math teachers will always tell you to check your answers, but most of the time we don't, right? I didn't check any of the answers I just did, because in many cases that would be very, very difficult. But if there is a time to definitely check your answers, it's when you're dealing with a radical equation. Because what can happen is you can get an answer, or what could be true is one of these answers may not work. or both of them may not work, or both of them may work. You could get extra solutions, and that's what we call extraneous solutions. So it is very important to check. So I'm going to go over here. I'm going to check. And I'm just going to take this by plugging it into the original equation. So I'm putting in -3 here for x. If I plug in -3 plus 7, what I end up with is the square root of 4. And if I put -3 on the right side, I get -3 plus 5, which is 2. And the square root of 4 equals 2. So that works. Let's check this one. If I plug in -6 here for x, -6 plus 7 is 1, so I'd have the square root of 1. But if I put -6 plus 5 into here, I get -1. And remember what we said about square roots. The square root of 1 is not plus or minus 1. It is positive 1. This does not work. This does not work, which means x equals -6 will not work. My one and only answer is -3. Again, this is what we call an extraneous solution. If you're wondering why that happens, it has to do with the squaring part. I'll doodle in this space right here. For example, this is just side note here. Let's say I took the equation x equals 3. How many answers are there to that equation? There's only one answer, right? X is equal to 3. But if I squared both sides, and I squared this side, I get 9. You can hopefully see there are 2 answers here, right? But this only had 1 answer. My original problem had 1 answer, but when I squared, I got 2 answers. And that's because I raised the degree when I squared both sides. And so when you do that, you run the risk of getting an extra answer. In this particular problem, -3 squared equals 9, but that was not my original equation, right? So -3 would be an extraneous solution. Okay. Now, another thing to pay attention to is you want to be on your toes here about thinking about things when you do these radical equations. If I've got a radical, I'm going to have to square both sides of the equation at some point. And so usually it'd be easier to square. I wouldn't want to square it the way it is. I would rather subtract that 5 over. And I'm going to be left with just root 3x minus 1 equals -4. Now, from here, of course, you can square both sides. And then you would get rid of the square root here and you can isolate x. But I can already tell you something about, in fact, let's just do that. If you squared both sides from here, let me rewrite this. If I were to square both sides, I end up with 3x minus 1 equals 16. Add that 1 over, I get 3x is equal to 17, x is equal to 17 thirds. I can already tell you that that answer is not going to work. You can try plugging it back in here and you'll see why. If I plug in 17 thirds, let's do that. So I'd have the square root of 3 times 17 thirds minus 1 plus 5. I want to see if that's equal to 1, a question mark. 3 times 17 thirds, the 3's cancel out. You end up with 17 minus 1, which is 16. The square root of 16 is 4, and 4 plus 5 does not equal 1, right? That doesn't work. Now, of course, we just mentioned that in the previous problem, when you square both sides, you run the risk of getting a solution that doesn't work. But since this is the only answer that potentially could have worked, there's actually no solution to this problem. And you could have told that sooner. The minute we got to right here, and if you just said it out loud, this is saying the square root of some stuff equals a negative number. There's no way that could be true, right? The square root of stuff cannot equal a negative number. And so if you ever see that, if you get to a point like this, you could immediately say there is no solution to this problem. You wouldn't even have to go any further if you spotted it. Now, if you do spot it, if you don't spot it, I'm sorry, you get an answer and you make sure you check it, you would figure out, okay, well, that doesn't work. So that was the only potential answer. It must be no solution. It's just, it's going to save some time if you can recognize it sooner in the problem. Okay. Yeah, and just to remind you, if you've got a square root, you're going to want to square both sides. But if I've got a cube root of something, yeah, I just mentioned negative numbers. Now remember, cube roots can equal negative, right? Cube root of stuff can equal positive or negative. Both of those are fine, right? Remember, the cube root of -1 would be -1. So this is fine. I don't have to say no solution here, but I do need to solve for it. So I'm going to cube both sides. The cube root of stuff cubed is just what's inside. -2 cubed is -2 times -2 times -2, which is -8. Subtract the 1, and I get an answer of -9/4, which, to be consistent, you should check. But if you plug that in, because I said if you square or cube, if whatever you do to both sides, you should check. So just a quick check of that. If I took the cube root of 4 times -9/4 plus 1, I want to see if that equals -2. 4's cancel out. -9 plus 1 is -8. And the cube root of -8 is -2, so it checks out. Sometimes you get radical equations that are a little weird, where notice I have two different types of radicals on both sides. So how do I handle that? So to do this one, I think it makes more sense to see what to do if you change this. We've talked about fractional exponents. This is x to the 1/4, and the 6th root of x is x to the 1/6. Now, what we've been doing to both sides with square roots is squaring both sides, or cube roots, we cube both sides. If I raise both sides to the 4th power to get rid of this, that isn't going to cancel, right? The 6th root of x to the 4th isn't going to work. If I tried raising both sides to the 6th power to get rid of this one, it's going to get weird over here. But if you write it like this, it's easier to see that there is a power that I could raise both sides to and not have any more radicals. What would that power be? It would be, the smallest power would be 12. If I raise both sides to the 12th power. Now you'll see why that's good in a second here. Remember, these powers get multiplied. 1/4 of 12 is 3. 1/6 times 12 is 2. And so you can see why that was a good idea, because it got rid of the denominators, right? So you're essentially looking for a power that would get rid of both of those denominators, which would be the lowest common denominator. Now from here, make sure we don't make that same mistake as the second problem we did. I don't want to divide both sides by x squared. You don't want to cancel out variables. You don't want to divide them out. Instead, we will move it over, factor out an x squared. That leaves me with x here, 1 there. And if I set x squared equal to 0, I'm going to get x equals 0. If I set x minus 1 equal to 0, I'm going to get x equals 1. It's pretty easy to see that 0 works. 4th root of both of these, right? And 4th root of 1 is 1, so is the 6th root of 1. So both of these answers actually do work. This might be a great time to pause the video and see if you could solve this one, similar to the way we did the previous one. All right, hopefully you tried it. If I rewrote that as x to the 1/3 and the 5th root of x is x to the 1/5, the power that would get rid of both denominators that I could raise both sides to in this case would be 15. 1/3 times 15 is 5. 1/5 of 15 is cubed. Same idea, I want to move that over. I can factor out an x cubed, which leaves me with x squared minus 1. Okay, you can break that down further, of course, but just showing you alternative ways to do that, I would set x cubed equal to 0, which gives me x equals 0. And if I set x squared equals to 1, another way to think about that is just what two numbers could you square to give you 1? It would be plus or minus 1. Or take the square root of both sides, but knowing that I'm going to get two answers because the plus or minus 1 works, I'm going to take plus or minus the square root of 1 on the right side, plus or minus 1. If you check those, 0 clearly works, positive 1 clearly works, and negative 1 works. The cube root of negative 1 is negative 1, and so is the fifth root. So all three of these answers work. One last problem. Just maybe a little more of a tougher problem. This time we have two radicals in here, and we know at some point we're going to have to square both sides. Again, reminder, you can't just square this, and square this, because you're squaring two things on this side. You can't just, you have to square the whole entire side. You can only do it once. Now, I'm thinking ahead. If I put parentheses here and square that, then I'm going to have to multiply out these two radicals that are squared. And a lot of times it's easier if you can get them separated. So what I would do to make it a little bit easier is I'm going to add this over to the other side. So I'm going to have the square root of 3x plus 1 equals 2 plus the square root of x minus 1. And then square this, square the entire right side. Squaring the square root gets rid of it, 3x plus 1. I'm going to write this one out. So remember, when you square this, you can't just distribute it. It means you're multiplying it by itself. So if we FOIL this out, we get 4 plus 2 square root of x minus 1 plus another 2 square root of x minus 1. And then the square root of x minus 1 times itself is just x minus 1. Let's combine these two. And we might as well combine the 4 minus the 1 is going to make this 3 plus, let's move this x over here, and then we'll combine these two to be 4 times the square root of x minus 1. I'm going to have to square again, right? Because I can still have a square root. But before I square, I'd probably be better off if I isolate this and move these two terms over to the other side. I don't want to square it right now. That would be really terrible. So we're going to subtract x, subtract 3, get rid of those. So we now have 2x minus 2. You can leave the 4 there or divide it. I guess I would leave it there. Square both sides. Here we're going to have to FOIL that out. That is 2x minus 2 times 2x minus 2. So it's going to be 4x squared. Let's do the middle terms together. That's minus 4x, which is minus 8x. So we're combining those. And then plus 4. Now, because these are multiplied, you're really squaring both of these, right? You can distribute because it's multiplied. So you're squaring this and you're squaring that. So this is going to turn into 16 times x minus 1. Let's distribute. And then we're going to make one side equal to 0. So we'll subtract 16x and add 16. Four x squared, negative 8 minus 16 is negative 24x. This is going to be plus 20. That doesn't look too pleasant. Notice everybody, actually, I was going to say is divisible by 2, but everybody's even divisible by 4. So what I would do is factor out a 4, x squared minus 6x plus 5. Whenever you have a constant, factor it out. It's actually, you don't have to worry about it because think about this. I could always divide both sides by 4, cancel out the constant, and 0 over 4 is still 0, right? And then I would factor this. X minus 1, x minus 5. This is going to give me x equals 1. This is going to give me x equals 5. It's been a lot of work, but remember, don't give up there. Make sure, because we know there could be an extraneous solution. So make sure you check x equals 1 and x equals 5. In fact, maybe you might want to pause the video and check. When you check, you have to check in the original problem up here to see if one of them doesn't work. Okay, if you try the 1, that doesn't look like that's going to work. That's going to leave me with the square root of 2 minus 0 is equal to 2, right? Root 2 minus 0 equals 2. That doesn't seem to work, right? Let's try the 5. I'm plugging that into 3x. So 3, now I better write this one out. 3 times 5 minus 1 minus the square root of 5 minus 1. And I'm trying to see if that's equal to 2. This is, that doesn't work either. Oh. Oh, I made a mistake. Look what I did. I changed that to +1, which means I got a bad answer there. All right, well, I'm surprised that factored. Um, let's not worry about that. I made a mistake early on. I don't want to. We can maybe do this tomorrow in class. How about that? We will do this exact same one and I will try to get it right. Hopefully, though, you still get the idea. Okay, that's it for now. Must be tired.